Cylinder head porting is a specialized process aimed at improving the airflow through an engine's intake and exhaust ports. By carefully modifying these passages, enthusiasts and professionals alike can unlock greater power, efficiency, and responsiveness from an engine. However, this process demands precision and expertise. Avoiding common mistakes is essential, as errors can lead to reduced performance, poor fuel economy, or even engine damage. Understanding the fundamentals and potential pitfalls is the first step toward achieving reliable and effective results. When starting out with cylinder head porting, beginners often make several common mistakes. One frequent error is removing too much material, which can actually reduce airflow and compromise engine performance. Many newcomers also overlook the importance of maintaining smooth transitions between ports and valves, leading to turbulence and inefficiency. These mistakes are so prevalent because the process can seem deceptively simple, and without experience, it's easy to underestimate the precision required. A lack of understanding about airflow dynamics and the specific needs of each engine further contributes to these early missteps. Over-enlarging the intake and exhaust ports in an engine might seem like a way to boost performance, but it can actually have the opposite effect. When these ports become too large, the velocity of the air and fuel mixture entering the engine drops significantly. Lower air velocity means less efficient cylinder filling, which can reduce power output and throttle response. Additionally, poor air movement can disrupt combustion, leading to decreased fuel efficiency and increased emissions. It's important to balance port size to maintain optimal airflow and engine performance. Creating uneven, short-side radii in engine components poses significant challenges. These irregularities can disturb the smooth flow of air through the intake or exhaust passages, resulting in turbulence and reduced efficiency. When airflow becomes unpredictable, engine performance may suffer, leading to inconsistent power delivery and potential reliability issues. Ensuring uniform radii is therefore crucial for maintaining optimal engine behavior and achieving consistent results. Melting aluminum during porting is a significant risk that can lead to irreversible damage. When tools generate excessive heat, often due to improper use or incorrect speed settings, the aluminum can soften and even melt. This not only alters the shape and integrity of the head, but can also create weak spots or holes. Such damage is typically permanent, requiring costly repairs or complete replacement of the component. Careful temperature management and correct tool handling are essential to avoid these issues. Leaving rough or gouged surfaces in the system can significantly impact its performance. These imperfections disrupt the smooth flow of fluids, creating turbulence that hinders efficiency. Turbulence not only reduces the overall flow rate, but can also lead to increased wear and potential damage over time. Ensuring surfaces are properly finished is essential for maintaining optimal flow and system longevity. Removing excessive material near valve seats can lead to serious engine problems. When too much is taken away, the valve may not seal properly, allowing gases to escape and reducing engine efficiency. Poor sealing can also cause increased wear on the valve and seat, potentially leading to premature valve failure. It's essential to maintain the correct material thickness to ensure a reliable and long-lasting seal. When the port shapes between cylinders are inconsistent, it can cause significant imbalances in engine performance. Each cylinder may receive a different air-fuel mixture or experience varied exhaust flow, resulting in uneven power delivery. This lack of uniformity makes it challenging to achieve optimal tuning, as adjustments that benefit one cylinder may negatively affect another. Over time, these disparities can lead to increased wear, reduced efficiency, and even potential engine damage. Ensuring consistent port shapes is therefore crucial for maintaining balanced performance and reliable tuning. When ports have been over-enlarged or left uneven, carbide burrs can be used to carefully reshape the surfaces. By gently guiding the burr along the port walls, excess material is removed and irregularities are smoothed out. This process helps restore the port to a more precise, consistent shape, which is essential for optimal airflow. Proper technique ensures that the corrections enhance performance without introducing new imperfections. To achieve a smooth, flawless finish on any surface, start by thoroughly cleaning the area to remove dust and debris. Use sandpaper or a sanding block to gently even out rough patches, working in a consistent motion for best results. For deeper gouges, apply a suitable filler, pressing it firmly into the damaged area and allowing it to dry completely. Once the filler is set, sand the surface again until it blends seamlessly with the surrounding material. Finish by wiping away any residue, ensuring the surface is ready for painting or further treatment. When working with aluminum, it's important to prevent the material from melting during porting. Using the correct tool speed is crucial. High speeds can generate excessive heat, increasing the risk of melting. Applying gentle, consistent pressure helps maintain control and reduces friction. Incorporating effective cooling methods such as compressed air or specialized lubricants can further dissipate heat and protect both the tool and the aluminum. By balancing speed, pressure, and cooling, you can achieve precise results without damaging the material. Maintaining even short side radii and consistent port shapes across all cylinders is crucial for optimal engine performance. Precision machining and careful measurement help ensure that each port mirrors the others in both size and curvature. Using templates or specialized tools can aid in achieving uniformity, reducing the risk of airflow imbalances. Regular inspection during the process allows for early detection of any deviations. By prioritizing consistency, you help promote balanced airflow and improved efficiency throughout the engine. Carefully reviewing your work is essential to achieving precise results. When measuring port dimensions, use accurate tools such as calipers or micrometers to verify both width and height. Double-check all measurements against your project specifications to avoid costly mistakes. Templates can be especially helpful, providing a consistent guide for marking and shaping. By combining thorough measurement with the use of templates, you can ensure that your work meets the required standards for accuracy. When it comes to cylinder head porting, there are several key mistakes to avoid. Never remove too much material, as this can weaken the head and disrupt airflow. Avoid creating sharp edges or sudden transitions, which can cause turbulence and reduce performance. It's also important not to leave rough surfaces, since smooth, consistent finishes help optimize flow. If you make an error, carefully blend and smooth the affected area, and always double-check your work to ensure proper shape and integrity. As you embark on your journey into porting, remember that every expert was once a beginner. Mistakes are an important part of the learning process, all offering valuable lessons that help you improve your skills. Stay patient and persistent, always prioritizing safety and effective techniques. With consistent practice and a willingness to learn, you'll gain confidence and proficiency over time. Embrace each challenge as an opportunity to grow and refine your abilities.